focal from into the reverse arm. So now you don't have to always wait for the fastnet. What's the best shape? Oh, for bioretention system? Yeah. Well, I'd say organic. It won't. First is on the plaza. It could be a full circle, right? But then if it's a roadside or to the side of the parking lot, it will be your shape here will be pretty appropriate. If it's in the middle, it's the same size. It's the same shape as the island. Okay, there would be some berms. So the actual boundary of the bioretention would be smaller than the circle, but you would try to maximize the area of the bioretention within the island. Mm-hmm. So the key thing is your connection point stays the same, but then you could curve it like this or curve it like that, right? So the connection point is determined by the curb height and the parking lot elevations. So they stay the same, but however you grade the inside of the island is determined by you. So as long as you keep, do not remove that contour, keep those two connection points at the same location, and the connection, the contour itself can take any form you want. Okay, we'll zoom in. Look at the big picture first. So you have that one at the end. From here, I can see you would need something over here, right? Yeah. Something over there. Yes, these are good. What you could do, you could actually shape your contours inside of the green areas more like this. So at least your green area is not draining to your parking lot. Again, the key thing is to keep these connection points correct at their original location. Change the direction of the ridge to a swell so that at least your green area would not contribute to the runoff, right? Yeah, so they would drain into the swell inside. Okay, so you had a few. I would say somewhere here, before it turns, there would be one, and somewhere here, and then one more here, and then at the end, so those are the 5. Yeah, the 5 that will be necessary in this area. This way, 1, 2, 3, 4, 5. You could more kind of evenly distribute it, 1, 2, 3, 4, and then 5 there. This one can be a little bit bigger to wrap around the corner, but don't have to be. But taking advantage of some flatland you have there might be beneficial. Then the other ones are at the right location. Okay. All right. I'm gonna zoom in to see the specific design then. Okay, let's look at one of these. So I need to know. Yes, you have a DI, so that should be okay. I'm trying to figure out your contour number. 08, and this 07 seems to be at the wrong location based on the distance. This also needs to be 50. That seems to be bigger than 50. And this is not kind of in between the midpoint here. Midpoint looks like it's there. So that seems to be the 1107 there. I think there is some offset issues there. Okay. Yeah, looks like you have to. That one seems correct. Just yeah, right. So that might be 107. If this is 107, that's 08. This is less than or higher than. This looks like it's higher than 0.5 because the distance from this corner to the 108 feels like it's smaller than half of the contour spacing, but double check that one. Close enough. So, okay, the DI is 1107.5. If the DI is 1107.5 and your LP is the same elevation, then you don't have any storage, right? Yeah, that's probably a typo. So it might be 1106.7. That's the lowest it can be. Okay, so this makes your water depth one foot. That's the maximum water depth. So you have a 1107 contour, that's correct. And we'll need to look at the other contours to see if these 5 point are the right location. So the 108 goes here. 07 goes there. You just need 107. You don't need another 08. And simply because we are not trying to, let's see. This is, I think you need 7 and 8. And this is another 7. So basically you only need one contour in this location. And then your high point will be between 7 and 7. Okay. So let me take a look at the other ones. I'll need to know where your curb cut is. Otherwise, it's hard for me to see. Oh, maybe it's blocked by my annotation there. We don't have curb cut elevation here, so that you need to add this one. If this is 10 contour, that might not be as high as 1109.95. Looks to me like 0.9 something. Yeah, if it's 0.9, and that needs to be 8.9, okay? Because the differences between these two cannot exceed. Well, if you have an RDI there, the RDI cannot be higher than your curb cut. So, during Tuesday, I was drawing the cross section. That's a bad color. If that's the curb, this is my vegetation side, and that is my parking lot side, right? And we're cutting a hole through here, right? And then we're trying to design something like this, okay? And then if my curb cut here, for instance, is 1109.9, if I don't have any RDI, wow, that's a bad color. 1109.9, if I don't have any RDI, my curb cut is the tallest, is the highest that my water can go, right? So that's my water height, okay? If my water height is 109.9, my low point needs to be 108.9, okay? And then we can see that we have a 1109 contour. We have a 1109 contour here, and that's the contour that is one contour in my bioretention. And then we'll see what my surrounding contours are, and then I'll decide where my height, the berms should be, right? But if I don't want the water to get as high as here, I could have an RDI that will lower the water down. Okay, if my RDI is higher, it doesn't work because my water will not enter anyway. Water will never get to that high because the curb cut is full. You could, yeah, you could lower it, right? You could lower it. Once I lower it to 1109.5, you can see that my water depth is now 0.6, but I can lower this down too, right? I can lower this to 1108.5 just to increase the storage depth. No, in that case, we're still, again, we'll have a 1109 contour in the retention area, right? That's that. So this is the relationship between all these all these elements. Okay, so if we understand that one, recalculate the CC, lower RDI, lower LP according to your RDI. We have a 109 contour. Again, we don't need the 110 contour anymore because it's not necessary to make it deeper. Okay, in order to make it deeper, you probably need to bring more fill, and then although the water level stays at 1 foot, the bank would be much higher than that. Does that make sense? So you don't need the 1110, you just need the 1109, and your high point will be in this area because the other 1109 is over here. Okay, so you have 1109 contour, and in between this 1109 and this 1109, you would have the high points. Okay, okay. So the high points will be between two contours that have the same number. Okay, all right. So those are the size. Let's look at this one. So you would want to cut your curve a little bit lower and symmetrically, just because you don't want just to receive water from one side, right? You want to try to receive water, even if you cut it here or lower it down a little bit. Water enters there, and this is how much water everything above this point will get inside. No, the arrows are backwards, sorry. But no, all these, it's going to drain into there, right? So it's able to capture water if you project a perpendicular line from your curb cut. And well, let's suppose that this is the one that you want to use. Now, again, I'm trying to figure out. So that's 10. So this is 9. Well, 8.75 is a reasonable calculation. And yeah, again, lower your RDI. Then your LP would work. If you lower your RDI to 108.5, your LP would work. And we have, see, this is 9. We have another kind of 9 contour here. Yeah, that's the 9 contour. In this case, you're correct. Here is it's done correctly. So you would have a 08 and 09 contour. In between, you have 109. If you want to make it bigger, you could do your 9 like this, and then these can be bigger. Okay, the 9 and the 8. If you have any confusion about how things should be done, always try to draw a cross section. So this is your curve, and this is your island. The curve is at 108.95, and so your 9 contour should hit the curve. That's correct. Should always hit the curve. your O8 contour is actually a enclosed contour just because everything is higher above the curve, right? Yeah. So O8 should be an enclosed one. O9 should hit the curve, and then you can enlarge them by moving the curve to the right. Yeah, but otherwise, mostly this is correct. Okay. You would need to. Yeah, you want, because you don't want the other side of the water just bypass water, right? Yeah. I think I checked every one of your the retention that's done. Any other questions? Oh, or any system needs, yes, you would need something by the lower plaza. Something could be done on the plaza for the roof water. And retention can be done off the slope of the plaza to receive water from your plaza. If your plaza contour is just like this, it will just sheet flow to the depressions. Does that make sense? Yeah. Yes, you have to, if you want to do a drain inlet, you have to, well, basically a concentrated access of the water. It needs to concentrate to a certain point. It might be harder than to do a just 2 of those or 3 of those retention parallel to your plaza. Yes. Yeah. Oh, no. They will be off the plaza because your plaza is paved. Yeah, the sheets flow off. So your plaza is here. And then again, your depressions will be like this. That's the edge of your plaza. Okay. Remember that there's no curb here anymore. We're not in a parking lot situation or not driveway, but it's on a plaza, so there's no curb. So you don't have to do like a curb thing, but just the edge of the plaza would be the elevation of your kind of the water entrance height. But again, you need RDI in this case because this is the end of the system. Without an RDI, you wouldn't be able to discharge any excess water. Okay. Yes, based off the edge of the plaza. Yeah, lower than the edge of the plaza. That's all right. Okay, I'll move forward then. Is Eric here? Let's see. Not from here. Nope. Okay, good. Okay. We'll take a look at the contours first. I don't think your parking lot has been dropped correctly yet. Some of them are, not all of them. Okay. So without the correct contours in your parking lot, it's not going to be easy to make sure that your retention can be done correctly, just because the retention elevation is determined by your parking lot elevation. So I see a turning of the turning of the contours better not be in the parking lot itself. So I'm a little concerned about, you might need to redo a lot of things at this stage. Let's see what's the least damage. Yeah. Yeah, none of these lines are parallel at this point. So okay. And it's now a swale. Okay, that's fine if you have a swale. But your swale, it's going, no, okay. 6 and 5. That needs to be a 6 again. Otherwise, it's going all the way. Um, Let me try to go back to canvas. Oh. We're here. We did the drop-in parking lot all together. Not sure what kind of feedback you got at that point. That's the review. Okay, let's take a look at this one. Yeah. So that's the feedback you got for the drop-in parking lot. Okay. This makes a lot of sense. I would follow this first. Okay. Now go back to the drop-in parking lot review PDF that Stuart has marked up for you. Okay, at the end of the PDF. Finish this. Otherwise, it doesn't really make sense for you to start the stage. Just because you know, if you start this, your elevations will be all wrong, and then you will need to start over, okay? The contours. You probably need to pull a document out, you know, or a recording out, but I don't think I don't think this looks like something that I would recommend. But definitely if that was on me, pull the record out and I can review with you. But last time, this is from 2 weeks ago, Stuart redrew that for you already. Okay, you just need to mimic what he did. Okay, mimic what he did, and then adjust the spacings to the correct 50 feet. If I said something like rotate your contours, I meant rotate the entire grid instead of individual contours. Okay. So should I put a retention here? Yes. Should I add more about retentions? I think you have retentions. Not sure this is necessary. Not sure this is necessary. You should have retention along your swell lines, which means somewhere here. If this is your swell line. Okay, this is your swell line. That is where, along the swell is where you should put your retention. If you have a retention on your plaza, it will be on your plaza like that. And then that will be able to capture water from this area, okay? That is the drainage area. If you want to cut a hole in your plaza, that one will be entirely on your plaza instead of at the edge of the plaza, because here you don't, unless this one is for the roof scudder or downspout, then that one makes sense. It's a little too close to the building, so you will want to put it away, because then otherwise it will have some damage on your foundations. So let's look at, well, the retention area here won't be able to receive much water because it's not on the drainage route. Your water is draining this way. Okay, the water is draining that way, unless your parking lot contours are this direction, then it drains to that side. Okay, and then that location makes sense. You need to look at where your water drains, and then downstream of that water, that's where you capture that. So for instance, if I go back to here, once you have that, you can see your retention area will be here, which is a really good location because that's where you have flat land and that's where your swell is, right? Okay. If I use this one as the where you should have your retention, here, there, somewhere here, somewhere here, somewhere there at least. If you want to add more, you could add more to this area, downstream area. So if you want to add more, you could make this one closer and then have two more in this area. On this side, same thing. 1, 2, 3. And then at the end, you have one more. Along the swell, you have one more. So those are the locations that you should have retention at least. And then I've got one of these along this plaza swell line. That's one for the plaza water. And then the back, and on the plaza, you would have something for your roof water. So I'm going to take a capture here. So those are the areas for retention. Now, suppose if I look at one of your retention area, if we assume that you are able to capture water from this area, you wouldn't have a curb cut or two curb cut in vicinity at the same elevation. The time that you have two curb cuts is when you are at the end of the curve. Okay, if this is the lowest point, if this is the lowest point of the plaza, no parking lot, that's where you have two curb cuts. Okay, if you are at a dead corner, you would have two curb cuts and then a DI. Otherwise, you have one. Okay, otherwise you have one. In this situation, if your contours are like this, and that is the dead corner, then you have a DI, you have another two curb cut close to the DI. Okay. So if your CC is 1105.25, your LP, it's at a good elevation, it's half foot, that's fine. You would have a 5 contour for sure. So this is your 5 contour. Okay. You need to label your contour there. And you'll need to look at what your outside contours are. These contours need to be connected to other places. Now they cannot be incomplete lines, okay? If your 5 contour, I'm not sure whether, no, this is probably 6 contour and is a closed one. So you would have another 6 contour around your retention area. So your 6 is probably going like this. Then in that case, you just only have a 5 contour, okay? Because you don't need to make it deeper. So 5 and 6, they can be adjacent contours, and then another 5 would just be connecting to the tree here, okay? Determining where your high point are is dependent on what your adjacent contours are, right? You can't only zoom into this area without looking at the bigger picture of the contours. Okay. All right. That's all I have to say on the submission. I do need to encourage you to make the parking lot revisions as soon as possible. And then if you have time still in this class, work on one of them, one of the retention area, come to me, I'll review it for you so that you have the correct understanding of what how retentions need to be done. Honestly, no, if you have been observing reviews on Tuesday, we have gone through all of the scenarios. Well, that's the point of having or asking you or requiring you to watch others' reviews. If we look at the schedule, next week on Tuesday, we are doing divergence swale. And then on Thursday, we're doing ramp grading. This is the only chance we're reviewing retention grading for you. Okay. There are 2 new smaller pieces that you'll go through next week. And then after that, we're reviewing swales and ramps instead. We will not return to retention grading if we don't have time. Okay. If your ramps and your swells needs our review, we cannot afford to come back to retention grading at that point. So the clock is ticking. I know it's stressful at the end of the semester, but it's time to really put in that effort so that things won't accumulate until the final point when you can't really get a lot of timely help. Okay. That's all I have to say for this one. Jaden, is Jaden here? Okay, Jaden, it's online. I see.
Yep, I'm here.
Okay. This berm in the correct area, HP. Okay, I'll take a look at that one. Does the drainage area currently go around my contours? Do the numbers agree? So let's see, 10. The contours looks pretty good. And yeah, again, I'll zoom in that one. Drainage in the correct area for the closet. That's either raised drain. Correct. It needs to have a raised drain inlet. Just point out not sure if there's a stairs in between your wall and your building. Looks like that's the stairs location. But if it's not, then you need to move the wall to the.
Yeah, I need to put stairs in there. I haven't done it yet.
Okay. Okay, we'll go through it one by one. Little bits of things that seems a bit too close to the next contour. Remember to correct that one. Okay, so the first thing I need to point out, it's not opened, the curb cuts and DI is not at the lowest point, okay? How do you find the lowest point? You find the tangent line. So if this is your parking contours, you move it until it gets to the tangent point, and then that is the furthest distance.
Okay.
So your curb cut in a DI will be in this area. Here. Ah, why does it go to red? Okay, that's where you have your CC and DIs. Okay, your DI essentially will be the parking lot elevation, and your CC will be slightly above it, maybe 0.1 above your BC. Okay, 0.1 or 0.5, 0.05, you have it at 0.04, that's okay. So let's suppose that your numbers are correct. You have 11105.04, yes, 05 contours there. LP is 4.25, that's reasonable because that means you have a water depth of 0.75, that's cool. And then 05 contour, I'm looking at, you can raise your OHP to 0.5 because, you know, that berm probably needs to be more pronounced. Where is your 5 contour? Your 5 contour is it's getting pretty, okay. So in that case, you actually need to close your 5. Your 5 is not connected to the correct one, right? 5 is this one. Oh no, 5 is this one. Sorry, my bad. And because that's under the tree, remember to add a contour under the tree. Close that one off. So somehow you made it pretty low. I'm not sure. So you will have another 5. Does that make sense? This is another 5. That's it. That's under the tree.
So would they both connect to that same?
This is a closed one. The tree one is a closed one.
Okay.
Yeah. Just because you need to preserve this area. Okay. This portion cannot be disconnected. Otherwise, you're killing the tree there. But because your 5 is over here, the other 5 needs to be staying closer to the other 5, the green 5. So that's why I kind of close this one this way. Okay. Well, I will actually zoom out and take a look at your entire contour just to make sure that that's okay. 10, 11, 12, 13, those are okay. Are we connecting back to 12 over here? 13, 12. This is 12. it might make your life a little easier if you basically raise all the number of your contours by 1. Basically because this is 12, 13. You're at 13 here. If you have your 12 being here, you'll need to keep moving your 13. Does that make sense? We still have a lot of conflict over in this area. So if the original contour is at 13 here, it might be better if you say this is my 13 instead of 12.
Okay, yeah, that makes sense.
Okay, no, 13, 12. And then all the way, then this one is 6. And then your 5 doesn't need to move. Well, part of the 5 doesn't need to move. You will only need to move until this point. Or, you can do something like this. Okay.
So would that change?
Make your life somewhat easier. Okay.
So would that change where would that change where the 5 contour is now, where it crosses in the plaza?
So if this is your 6, 6 will connect here, and then your 5 can stay where they are, right? This portion of 5 will stay where they are, but then you need to drag this tail of the file 5 to the side of the building. Okay.
Okay. So then, and then the one in the center would stay where it is. That intercepts in the center of the plaza.
The plaza will, this will just become 6.
Okay. And then that one right below it, the one that you drew in, would be the major contour. That would change color.
Yes, it will change color because it's not a major contour anymore.
Okay, yeah, that's what I was wondering, because I was confused if you were telling me that I need to change like the center, like of that green one that goes out around, or not.
No, you don't need to change the shape of the contour. You just need to change the connection here, right? Originally it's connected to 5. Now you connect it to 6. Okay. So this one is actually, wow. Yeah, this one actually needs to connect back to 12, and that needs to connect back to 6. So you move the connecting areas for it to connect to one contour above. Okay. So yes, these needs to be adjusted, but it's a relatively small adjustment. Then I'm saying I need to reconnect all these to make 13 or make 12 work here. But actually this can be 13, so you don't need to change the grading in this area.
Okay.
Okay.
And would they change, would I change, sorry. Would I change them all like straight down to the bottom of my building and retaining wall? Like where it starts at 1095, would I make that 1096 then?
So yeah, your TFFE now will actually, well, the original number were not correct. Even if this is 5, the TFFE is actually 5.5. So now TFFE would be 1106.5. Does that make sense? So your BFFE will be 1096.5. So here you would have a 6 contour coming out of your the back plaza. And then you'll need to look for where 6 is, where originally 96 is. Originally 96 is actually here. Again, it actually makes your life a little easier that way.
Okay.
Yeah, you don't need to drag many of these contours up to connect to the wall anymore. Your 96 can be right there. And then your 5, well, on the lower side, on here, your 96 will need to move to make it work. But on this side, you're actually making less grading in that
area.
Okay. Okay. Again, it's not a big change. You'll adjust some layers, you'll reconnect to adjacent contours, but overall the pattern stays the same. Okay, let's take a look at this one. So if this is an 8 contour now you can see this curb cut, it's not 1107.04. It is below 8, right? It's below 8. So it's 91107.95. Does that make sense?
So that would be the curb cut. Okay.
Yeah, that's the curb cut. So I guess there's a little bit of a confusion about the directions. So curb cut determined by the parking lot elevation. You don't need a BC, well, you don't need a DI. So we're duplicating some labels here. Because if you don't have a D, this is not a dead corner, you do not need a DI. Only when there's nowhere for the water to go, that's the situation where you would have a DI. Okay. So
Okay.
in this case, you can have an RDI, but you don't necessarily have to. Just because water can keep flowing down, that becomes its own overflow mechanism, right? So no DI, you don't need a BC and the CC, right? If you have a curb cut, that's your, you only need curb cut elevations, and that CC is your BC, okay? So you do not need this, you just need a CC 1107.04. You do not need TC here because you have a curb cut. You don't have a curb in that spot, right? Your LP, actually, your LP makes sense if you have the right curb cut elevation, right? That means you have a 0.7 depth for your water. In this case, you will have a 7 contour, right? Because your curb cut is lower than 7. If you want to have a 108 contour, it means that actually you're feeling the slope of the cell, which is unnecessary. You could have, let's see, I want to scroll it down. I want to see where the other contours are. Okay, so if this is 8, that's 7. So 8 contour comes down here and then goes out like that. You will have a 7 contour. In that case, your 7 is kind of at the, sorry, 8 contour, my bad. 8 contour will hit the curve. That's correct. Let's draw it. Otherwise, it's going to get confusing. So 1107.9 there. And your bottom is 1107.25. So you don't have a 7 contour. My bad. Misspelled. And then your 8 contour is like, it's like here, right? It's hitting the wall there, hitting the curve there. So you're drawing it along the curve. That's good. Then 8 contour. You have an 8 over on the east side, and that's where your high point needs to be. Does that make sense? So this is 9, yeah, and your 8 comes on here. So your 8 and 8, between the two 8, you would have high point. We're missing high points
here. Okay, so do I need to? So that means I need to change my actual contour needs to change, or my bioretention area needs to change.
So for now, I would not change the shape of the contours. I would add the HTs in just to make sure you have all the correct elements in there. So you just noticed that we have a lecture on divergent swells on Tuesday, right? When we talk about the divergent swell, the contours here would actually change, okay? It won't change, but no, for now, let's keep the right elements. And then once we go through the divergent swell, you would know that your contour shape of 8 will change, okay? So this is actually a reminder for all of you that are directing water to the side. it might be good to hold off on doing retention on the side, because once the divergent swell is added, those by retention will change. Okay, work on the retention in other areas first. Prioritize them instead of this one. Okay, this one you know how to do it. That's great, but once the divergent swell goes in, things will change in this. Okay. So for you, your elements that's missing is the high points. The curb cut elevation needs to be changed. PC, move, remove it. BC, DI, remove it, and then that's it. Okay. That's for
So
this.
do the high points need to go inside of the retention? That's the one thing that I'm still
Oh
confused about.
no, it doesn't go inside the retention. So in elevate in cross section, it looks like this. It goes like that, goes flat, and then goes like this, and then goes like that, right? So this is where your 1108, the other 1108 is at. This is where your 1108 is inside of the retention. And here is your high point. It doesn't go in there. It's situated between the two 1108 contours.
Okay.
Yeah.
So it's just in between those two contours. That makes sense.
Yes, yes, in between the 208.
Okay.
All right. I'll take a look at another one. So for this one, yes, you have to have an RDI. You have an LP at 104.25. That looks okay. So, okay. On Tuesday, I went through this with the other group. I'm going to do it one more time. Now, on the plaza, again, if I'm drawing cross section and I'm drawing downward, okay? In the plaza, there's no curve, right? There's no curve, and space, it's sort of limited. If I want to create a retention like this, you can kind of see how my storage is limited, right? So again, the idea is the same. You might want to create a retaining wall at the end so that you will be able to hold a little bit more water, like that, right? Or you could change the wall to be vertical, on both sides, then you have more storage. Okay, but the key thing is on the plaza, you need to be mindful of not only the entrance elevation, but also the exit elevation. Okay, if I clear is along the swell, you need to know what this elevation is, but you also need to know what this elevation, that's the exit elevation. Okay, so if I go back to the cross section, you do need to know these elevations to be able to say, okay, this is the wall, that's the height of the wall that I need to create so that I can have this level of depth. Okay, so in your case, you would calculate this one. It's pretty close to 1105 contour, so that might be 1104.75, right? So if you want to have your bottom at 1104.25, that's okay. That just means, you know, you have, well, it's pretty shallow for your design. In this case, it's more important for you to have a retention on the other side of the plaza because you have much bigger impervious surfaces there. No, you have a smaller drainage area on this side. So it's more important to do this one instead of this one. It's pretty small, right? Pretty small and might not be worth doing it. You might as well do something once you're off the pavement. Then you can get pretty big retention area there. So for this one, now if your RDI is actually at 0.5 and your low point is at 4.25, your water depth is pretty limited. It's 0.25, okay? It's pretty limited, very shallow. So you might want to consider I'm gonna change my LP to 0.5 below my RDI. That make more sense. Okay. So let's suppose that we're changing it to 1104. 1104, this is 1104.5. So now the key thing becomes on the lower side, you need spot emissions here, okay? And this will be expressed as what? PW and BW, okay? The BW would basically be, BW will be basically be your LP elevation, right? The TW would be that elevation, and it needs to be higher or equal, at least equal than this one, than that one. That makes sense? So that's when you're creating a plaza. Those are the key points that you need to keep in mind. Any questions?
So yeah, so when I go to actually put like the wall behind, so the wall would go directly behind the retention area. So would that literally just be like a rectangle behind the area?
It would be something like this.
Okay, yeah, that makes sense.
Yeah.
Okay, thank you.
Anything else you want to go through? Overall good progress. I see the parking lot are correctly correctly dropped. I don't know if you need these lines. These are some of the, not sure why there is a gap between your
Oh, it was because that was where my sidewalk was and I turned it off for this submission, I think.
Yeah, but then you actually still the line should be go along the curb
Yeah.
instead of the parking lot, right? The sidewalk is already at the vegetation level. It's at the
Yeah,
higher level. Yes.
Yeah, I need to change that. I
Yeah.
see that now.
Yeah, that's a little
I think that was the only spot that it happened in that I can see.
yes. I think everything else looks pretty good in terms of.
Yeah, I also have just like one more contour on the bottom left side that I still need to close. I forgot about also.
Yep. Yeah. Correct your TFFE and BFFE, and that's yeah, overall looking good.
Okay, thank you.
All right. So I see Roy there. Okay. So I think we're missing a contour somewhere here. Well, let's see. This is where it goes. That one, sorry. This one. You see you're missing a contour here? Only this part. Only that part. Okay, I was just drawing to find out where things are. We're missing one contour here. Let's see, anything else? We are having that one. It's a little strange. The contours here are a little strange. So, not sure if you have one here and one there. I'm pretty sure you have one more there. Okay, if that's the case, then this connection is to happen in between here. All right, and that needs to come out over here. Does that make sense? Now it looks better. Okay, so that's the, and here it needs, this one is to wrap back around to the wall. Oh, that's your ramp is not long enough just yet. Okay, so you might as well, well, we'll wait until next week to do the ramp, but that cannot hit the ramp and then close. It needs to be attached to a retaining wall somewhere on the side of the stairs. That 108 contour, okay? Yeah, we'll talk about divergence swell in this area, so no need to work on this just yet. And okay, 103, 1113 seems to have disappeared. Where does 1113 go? 3 comes to here and then it's gone. And this is definitely not 109. So let's take a look at that area. Okay, so at this scale, this is what needs to be changed. And I'm going to zoom in to your entrance drive area. Okay. 1103 is not at the right location. Originally, that connects there is the connection, but not the one inside of 113. Okay, your 1113 would be somewhere here. If we're following, well, I guess we're not following anymore. Okay, let's see. Trade again. Yeah, your 3 actually goes. This 3 doesn't appear on the parking lot if you want to, yeah, it's somewhere here, right? If that's the, so your 3 needs to connect here and come along there. 313 might just be there. Okay. I'll need to see where 13 is on the other side. Let me zoom out. Seems to be that this is the 13. Okay. Yeah, this is 13. That's where 13 was. Okay. Where 13 was, you don't have a 13, but you have a 13 connection along the curve over there. So we can stop the curve. We can start the curve after you have 13, so you don't need to deal with the curve when connecting 13. So your 13 can actually go like this and then just basically do this. That's okay. Right? And then your 12, is originally hitting here, and then I can ask it to go out here. And then you would have something in the middle. So this was the original one. Let me do that. And then 12 needs to go from here to there, connecting back there, and then I'll need to find where 12 connects. Okay. Well, there's a 12 over here. So deleted a wrong line. Okay, this is your 12. And that is your 12. It might be good if you do something like this. You know, we're having a transition. So 12 goes like that. That makes sense? Yeah, that still stays there. Yeah, you could actually use this to turn that one in the middle. So if you want to imagine how can you get here, then that's how you get there. The 12. So in this case, you're correct. I want to actually retain this portion. Does that make sense now? So your 12 actually turned one time. The original, let me change color so you know when this one would be the original one. Cannot change color, but redo it. So this is what have made your current 12. That makes sense? Yeah. So the red line is the original one. The 12 is after you dropped your parking lot, and you will retain up until to this point. That's your 12. Okay. 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 Now, yeah, it makes sense. Pretty sure you're missing one here as well. There's a small one of 10. Okay. Does that make sense? Yeah. All right. So that's the contour. Let's zoom in. So same comment. When this one is not at, it's not along the ridge, the valley line. Your valley line is here, right? So it needs to be somehow connected to the valley line, or you can make it entirely on the plaza. Because if I don't have a trencher or some sort, nothing is going to drain into there. Make sense? Because your water is draining this way, right? Nothing is draining into that way. Only if that, only if that I have something, a drain of some sort over here, and then I direct water to here and then to there. You need, if you want to have a trench drain over here, then you can design something like this. Okay. Yeah, but I would know, naturally there wouldn't be any water draining into there unless you have a drain of some sort in the system directing water over. Given that your swale, it's so close to the turnaround, I don't recommend that you have your entrance right here because it's so close to your turnaround. So your idea of having a trench drain of some sort over here, that works. Okay. Or you could move your retention entirely to the middle like this. Okay. All right. So that's that one. Quickly. If your RDI is 107, your LP is 0.6, and then there's a 7 contour, 7. So the contours here are correct. But if you think of the space, every space here in adjacent is above 8. But you have an RDI of 107, meaning that you have a pretty deep hole. Okay, so this is my plaza edge, right? My water level is at this level, and that's at 1107. And here the edge might be 1108.4. So you have a 1.4 drop. And that requires that you would have a wall there. And I don't think that's your intention. I think your intention is actually, this is relatively shallow. So you should move up these elevations. Okay. Otherwise, your flow would be pretty, even if you have a trench drain, at the surface elevation is 108.4, then the bottom of the trench drain will be 108. Even with that elevation, having another foot of drop of water getting into, it's not necessary. Now, if possible, make the entrance pretty gently sloped. Okay, do not create big drops unless you're creating a waterfall, which is probably not your intention in this case. Okay. All right, let's look at this one. So contour here is L8. Curb cut is 7.75. You do need a DI elevation, okay? You do need to calculate the distance and have a DI elevation. And I think you haven't calculated this one yet, but it's okay for 107.75 to be the CC. Suppose the DI is 107.65. Your LP makes sense. Your 107 contour makes sense. The other contour is the other contour. This is the 08 contour. Okay, that makes sense. Well, you have an 07, you have 8. Here, you do not need HP. You only need HP over here because you have an 08, right? Yeah, but you only have you're at 07 here. Well, granted that the location needs to be changed. Give me a second. So that is probably about here. Oh, I mean, the connection is probably about here. So that's your 08. This area will be a little bit smaller than you originally had, but well, or you could wrap it around like this. So you can create a bigger cell in this, okay? But you don't need HP in this case because this is 07 and that is 08. It's already lower than the outside contour. Okay. Yeah. Sounds good. I think you get now how these are done. Most of the relationships are correct. In some cases you created deeper than you anticipated. So that's okay. Some contours missing in this area. You know, if you cut through some, you have to close the 13. And then some conflicts here, you need to cut this smaller. All right. Yeah, this area will continue to change, so don't worry about that yet. Definitely make sure, definitely make sure your contours are hitting the wall like this, right? Some of the contours are still hitting the wall in 90 degrees, which actually encourages the water to flow along the wall, okay? Especially here, even smaller than 90 degrees. So these are a big category. Drainage is 15% of the final grade. When you have drainage along the wall, that's a really big deduction. Okay, it's an easy thing to fix. So everybody know this category, it's an easy thing to get the full points. If you basically check all these wall connections. Okay, that's all I have to say. Anything else? Okay. Back to you. Okay. Okay. So refer to your exercise 3. As long as your retention areas are larger than those, then you're fine. Okay. You know, make them as big as you can. If you have more space, make them big. Right. For instance, I can see a situation where you have, you know, the connections are here. If you want to make it bigger, you just drag it. Yeah, and then the inside can be bigger like that. All right. Yeah. So that's that. What can my bioretention system look like in this area with the tensions? And close contours. Okay, so we're doing trench drain over here. And oh, okay, all these are trench drains. The key thing So what, in terms of the contours in this area, you need to make sure these points don't change, right? Those are the curved connections and they cannot be changed. The things are what happens with the sidewalk can also be changed. Okay, if I want my sidewalk to slope to the well, for now, the sidewalk here is sloping to my green area, so I can keep those. And sidewalk here are not sloping to my vegetated area, so I can turn it. Okay, I can turn this. So my sidewalk also drains into my green area. Now I just need to find out a way to connect that and this, right? And you can adjust the connection based on your retention area. For instance, for the first unit, my entrance point is here. If I want to encourage this unit to be big, I could connect like this, and then my unit can be as big as I want. Okay. And then there's really very little restriction now for the rest of the ones. You can basically connect like that. Well, visually, because your tension is like this, so you're trying to create the rhythm like that, right? So you can kind of use that as a division. So let me go back. So make it a little bit smaller. So that's my first one. And then this wraps around the thick, wraps around like this. And then this is my second unit. And then that wraps around like that. And this is my third unit. Right, make sense? Okay, so that's basically how to keep, well, am I off by one? Oh, I'm actually off by one, sorry. That one is, oh, okay. Sorry. Okay. Use a different color. It's actually going to this one connecting to that one. That one connecting to this one, right? And this one connecting to that one. Is there any other connections there? Did I do it wrong again? This is correct. There's one more here that is connecting to somewhere. I think something turned. There are some contours turned. Let me clear so that I can have a better vision. Oh, 8 goes like this. Oh, okay. Something turned. That is your 9. I'm turning that over, so that is your 9 instead. Looking for another 9. 9 is over here. So yeah, the first one should be connecting like this. That is 8. 8 is here. And 8 is somewhere here. So that's that. And that's 7. This is 7. So this one would basically, well, this one can stay the same, can stay where it is. Okay, I think that's correct. All right, well, now let's get into how to do it. So this one is not necessarily a dead end, basically because, you know, these elevations are still lower, right? It still can get into, you know, to keep flowing down the curve. And that's not necessarily a dead end, but this one is not, this CI is not collecting a lot of water. Can you see that? It's not collecting a lot of water because it's parallel, sort of parallel to your contours.
So it might be you would have entrance. It's actually good if you have curb cuts along here. But even that, you're only receiving that much water, not a lot of water. Here, this location is where it's pretty low. Okay, let's do a middle ground. Let's just do it here, okay? So that much of the water coming all the way, let's see. This receives that much water. Basically, everything flows that way. If there's no other intersection, it will go down. That way goes back to New Jersey. That goes over there. Yeah, adding up this portion as well. So that's your drainage area, right? And if I have a trench drain here, I will calculate the elevation on the parking lot level, and then I will drop a half foot because there's a depth of the trench drain. You can specify the depth of the trench drain at half foot. So you calculate the surface of the parking lot elevation, keep going down. Okay, keep going down up until you get to the edge of the sidewalk and then drop like that. So we'll use the one that you have here as an example, okay? Many trains are a little bit more complicated. Okay, so you have the calculation of DI equals to 1109.23. Now we have to continue to drop by 2% until you get to the other side of the sidewalk. So you measure this sidewalk. It looks like it's a 10 foot. Okay. Yeah, it's a 10 foot. And then 0.2. So the surface, again, that's the top of trench drain, is 1109.23 minus 0.2. Okay. So again, I'm going to draw a cross section. We have a curb. We have a sidewalk. The sidewalk might as well just be sloping to the green area. This is 10 foot. And this is the surface of our trench drain. That is the bottom of our trench drain. Okay. So we calculated this one. We continue to drop by 0.2 to get to that one. And then this is where our water comes out. Water comes out here, okay? So when you are using a trench drain, we are in fact creating a deeper one, okay? You can see that the wall on the other side of the sidewalk, it needs to be higher. It needs to be 2 curb heights. So, okay, now the entrance of the water would be 1109.03 minus 0.5 equals 1108.53. Right? So that is the height of, that is this elevation. Okay, that elevation. Once we have that one, in this case, if you have a DI, then you don't need an RDI. Let's see. Yeah, I wouldn't recommend DI here, just because when you have a DI, you would need the 2 sets of CC around it, right? And in this case, you can actually have a curb cut and then RDI inside of the basin. So let's do an RDI in the basin. And the RDI would basically be a little bit below 108.53, right? And in that case, then you would have a 1108 contour in your cell. And then you look around and see which other contours that I need to have, right? Basically, you just need, you can have 8 next to 10, right? If you have that situation, you just need to add a 9. Okay, cool. All right. Good. Any other questions you want to go through? Yes, yeah, this will be fine. Yeah, that will be fine. Because no, you're at the end of the cell already, and we are look like we're crunching space here. Yeah, right there, you would have your ramp actually being in conflict. So later on, you would probably do something like this. So that your ramp wouldn't be necessarily in conflict with. So then in this case, you have something tucked in the cell here. Yeah, okay. So I'm gonna a little bit over like that. You get the idea. This will be in the middle. The green thing will be in the middle. Okay. Yeah, no problem for you to combine those two together. 104.92, 104.91, and 104.42. Cool. HP. Yeah, those numbers are pretty good. Good. Alrighty, I'll move forward then. Cool. Page. So we went through the contours. There are some contours you still need to correct. Okay, there are some things over here. Let's zoom to see your questions. Okay, you won't have retention area in this area because there's no water. Okay, it's higher, and yes, you would have retention areas here. You do not need a trench drain in this area. Well, I can see that you don't have a lot of space. You do not have a lot of space once you put your ramps and well, the wall can go along the building edge, and then the thing that you need to fit in here is actually a ramp. Yeah, some ramp here, but the ramp can go around. Necessarily have to have a retention or a trench in this area. You have a relatively small drainage area for this side of the plaza, so I would just put something over here. Okay, but you have a relatively larger one here, so it might be beneficial to put something in the middle. Yeah, like a circle. Yes, yeah. So we'll take a look at the details now. Okay. We wouldn't put something here again because water is not draining. It's draining this way, right? So you wouldn't be able to capture water. This is draining away from this curve. Yeah. So that one is not necessary. Well, we can look at the numbers. Suppose water is getting into the curb cut. The curb cut needs to be determined by calculating from here to there. So it's likely 107, right? It's not along the middle like in here. Okay, 725. So your RDI equals to 25 works. LP would be 6.75 or 6.25. You don't want to make, all right? But HP looks good. Okay, so we'll take a look at the other one. For this one, same comment. You need to move it to the lowest location, lowest elevation. So that means here. that point is the furthest. Okay, so this is the lowest point. That's the lowest point. And then I'm gonna erase that one. So that's where your CC and DI, DI needs to be, okay, or RDI. You have an RDI, that's fine. If it's inside, it's an RDI. So remember to correct that label. Looks like it's pretty close to 107.05. You do need to measure the distance from here to there. From this line, yes. Well, if it's 50, then no, it's right there 105.0. We're not going up, we're going down, right? Unless, okay. Well, let me see your contours. Yeah. So brown is original, that's 7, and that is 7 then. This will not be 8, this will be 7. And then that feels like more parallel. Okay, and then we have one more here. And then that goes like this. But now we have to drop it. If that's the middle, well, it feels more, that distance feels better. Now this more looks like the spacing based on what you have there is looking like that. So this is not yet, but you in CAD, so it's probably really close to 5.1. Okay, so yeah, using the 6 to measure from, but this is the brown. Brown is the one that's not dropped. So the brown looks the, the 7 and the 6 contour look like this. That makes sense? The 6 goes, yeah, if 6 goes like that. That's your 6. Okay. So curve cut will be probably 105.1. And let me move that on. So everything else needs to be dropped. Okay, everything else needs to be dropped because you have a LP currently above. Make sense? So the LP, what the number was based on your curve cut equal to 107.00. But in here, we're still going down, right? We're not going up, we're going down. So the curve cut elevation is not. Okay? Yeah. And because of that, your 06 contour was not correct. And 06 needs to be like that. This is 6. 6, it's there. That's your 06. And 5 can go around. So no 06 here. And then there is a 5 contour. There's a 5 contour here. Inside of, there's a 5 contour here. And then you would have high points between the 5 and the other 5. Okay, you can actually make it pretty big, given you have so much space. Well, you would have this one collecting the dirty water, okay? And then you can have another one closer, capturing the relatively clean water. Okay. All right, that's that. Yeah, you can have a bench all the way around. Yeah. So we're looking at this one. The location of that, it would be better if you move that one to along the swale. Okay, otherwise it's again it's pretty high, right? It's on the high side, it won't capture the water. Okay. No, you use the entrance of the water. So where the water is, right? Your RDI will be attached below that one. Yeah, that's because water flows down. If I don't need an RDI in the case where I'm one of the middle cells of the chain, then you don't need an RDI. But at the end of the chain, you need an RDI, and then RDI will be lower than the water entrance. Okay. All right. I want to go over just one more time. If you're in the plaza, I'm cutting a hole in the plaza, but my plazas keep, it keeps going down, right? Unless you want a pretty deep hole, my water level becomes like this one. So it be determined by the lower side of the plaza. Then I have a pretty deep hole, looking like this. Does that make sense? If I don't want that deep hole, I would need to put a wall here. A wall on the right side. That becomes your sitting wall. And you can have even all the way through. Like you drew here, if you have the sitting wall kind of wrapping all around, then that's what it looks like. The sitting wall will be like that. And that's your sitting wall. And yes, yeah. And in this case, your water level can be raised to here. And you don't need a big hole. Okay? Cool. Anything else? Okay. So TFFE will be about 7.5. Reason being that this is 7. Yeah. Yeah, yeah, yeah. Your TFFE will be 7.5. Mm-hmm. Okay. Yes. Yeah. You would again cut holes here on the plaza, and then you would have something at the bottom of the slope. That's for your plaza, and these can be for your roof. Yeah. Okay. All right. Okay. Hello. Question being, would the drainage system of the curb have a CC? Nope, it doesn't have a curb cut. It does have an RDI because it's the end of the chain. Yeah, it's not ZI, it's an RDI, yes. So let's take a look at the one that we drew for the end of the plaza. Okay, that's your swell. It's receiving water honestly from the contact, kind of the boundary that's in contact with your cell. So we'll just say, the entrance is about 1106.6, something like that. And your RDI, you push the RDI below, kind of, oh, okay. So your current DI is actually below your LP. meaning that water gets in and it gets into the DI. Yeah, it doesn't retain water, right? So you would want, my plaza's here. I'm creating a retention area here, and this elevation around here is 1106.6, and I can pinch it down for a little bit. Is it? So my water level can be controlled by my RDI, right? The RDI can be a little bit lower, say 106.5, right? Then the bottom 105.5 makes sense, right? Meaning that you have a 1 foot deep cell. Now we look at, we will see, okay, we'll have a 1106 contour there, closed contour. Does that make sense? Yeah, so for now, you didn't draw it as a closed contour yet, but draw it as a closed contour. Okay. And then the other contour here is 106, so you don't need a 107. Okay. Now, your other 106 is right here on the other side. So basically what I can just do the berm like that. Okay, so that's your high point there. That needs to 106, 106. Okay. Yeah. That's that. Yeah, and remove the 107 contour. It will be 6.5. Yeah, your 6 is over here, right? Yeah, the 6 is over here, and the high point needs to be higher than that. Okay. Okay. We'll take a look at this one. The same, this one has the same issue. So sometimes you need to, other occasions you need one, but when you have to just quickly draw a sketch on side and see, okay, in this section, I only have 106 in my retention, and then look around. Next contour is not 8, it's 7, and I don't need one. If the next contour is 8, then you need one. Okay, because you cannot have a 6 next to 8. Okay. All right. So you would need something over here, right? At the furthest end. Cut this one. So this is the end of the chain. You could have one additional as you drew here, no problem. I would recommend so. Yeah, I would recommend so. You can move this one up, right? You could move this one up and say, I have one more here, but then I have a bottom one that's bigger because that's the end of the chain, right? And this one is the one for the plaza, so that one still stays because this one is for the plaza. Is the green water, little cleaner water going here, and this one is for this chain all the way down the drop off area. Okay, so we'll take a look at that one. This one doesn't need, because this one is not the end of the treatment, the one that you do, it doesn't have to have an area. But the one that's down here, you would need a DI or an RDI. So either way would work. Okay, we'll take a look at the elevations here. So that's 7. Okay, your CC equals to 6.5, cool. RDI good, LP good. And you have a 6 contour. Yes, yeah, you have a 6 contour, you don't need a 7. Cool. I know in Stuart's videos it has 2 contours. You could have them, but it's not that necessary. All right. Yeah, okay. So the curb cut, it's very close to the contour, so it wouldn't be a 0.4. I think you might have calculated top of the curve or something. Yeah. Yeah, this is a 9 contour. Oh, is it? This is a 10 contour. This is 10 contour. Yeah. So it will be 10.2 something. That's 10. 10.2, 3590. All these numbers. Yeah, these numbers make sense. Yep. So you got it. You pretty well captured with the metric. Don't change. Yeah, for this side. Continue to do, let me see if there's any other deadlines between now and then. Let's see. I don't want to give you directions, say not working on it, but then no, you have something due and then you do it. That's not, there's a final here. Well, I guess for interim retention, you still need to keep doing all the retention. Yep. Yes, otherwise everything is good. Okay, let me try to zoom out and see if there's any other very clear things that I want to know. Yeah, some fuzzy connections. Like this one, you would have a connection somewhere here. Okay, because this is the middle point, right? So the connection there doesn't look right. It needs to be between two contours in the middle. So this is 10, 11, 12. That is 12. Yeah, this is 12 and that's 12. So you would need to find the middle point to connect, meaning that my 12, I would find a line that's in the middle, and that's my connection point. That makes sense? So my 12 needs to connect here. Oh, yeah. I probably drew that, but I didn't correct the connection. So what I meant was your 13 can stay here, your 12 can be here, your 11 can be there, but the connection point would correspondingly would change, just because no, this needs to be from between 12 and 11 in the middle. Just the connection needs to be different. Yes, yeah. You don't do the 25 anymore because this push is deeper. You basically find a line in the middle of okay. I know why it is that. Okay. We are keeping, I know where I did not. We're keeping the slope as the same for the entire parking lot. That means my green area, the whole green area, would be 2%. But once we get to this area, it can be significantly above, right? And that's what we're doing. We're making that portion pretty steep. So it wouldn't necessarily be in the middle it would be closer to the 12 and closer to here. You are correct. You're absolutely right. So it just looked a little fuzzy when I was, well, yeah. So this can, yeah, this can connect like that. Yeah. Basically you have a transition area. Yeah, in the green area. Yep. All right. Okay, I see Sender from online. Sender, are you here?
Yeah, I'm here.
Okay. All drop-offs in parking lots. Okay, how should the contrast environment interact with the contrast outside of parking lot and pavement? Should there be retention area in the center of the car drop-off? Yes, yes, that's a yes. Let's take a look at the one that you drew. So for this one, I would in fact move it over to here, because water comes out of the curb from this place, right? You can have it there, but for this one, you don't have a big capture area. So you're capturing all the water from this area only. Does that make sense? The retention that you currently drew only deals with, well, I'll probably need to see, okay, this is also your plaza area. So that's how much area you're capturing. It's a relatively small area compared to the entire entire plaza, right? So what's more critical to have, let me zoom out, is something along your swale that eventually captures everything. Okay, so everything eventually will flow into your cell. So it will be a pretty big one at the end of the chain. And that's where you have a lot of space. Does that make sense?
Yeah.
So you would have one here that is for the, well, if I change it to a brown water, you would know this is for the parking lot water coming out, and the green one is for the plaza. I would suggest that we reduce the plaza area. We have a fairly big plaza area, so you could actually start your pavement somewhere here. Well, even if you want to wrap it around the bus drop off, you could do something like this. Okay, so everything in between, it's green. Don't know if it was, no, if you forgot about one parking, oh no, plaza line, or was the big plaza your intention?
The big plaza was always the intention, but I was actually just going to ask, if you didn't mention it, I was going to ask if I should change that into like a green space instead. So I'll do that.
Yeah, it will be much better. Even maybe drew it even bigger. So you basically outline where people have to walk, right? So from here, I would have that area, and then I would have this much area for people to walk to my building. And I can even cut a big hole in the middle. Could do a green one in the middle. Let's see, if the entrance is over here, then I would probably do two. One is a big hole here, and then the other one is here. So I keep the path open for people to walk over here and walk over there. So you delineate where you definitely have to have pavement, and then the other places you could cut it out, you know, and make it green. Okay. All right, so those are the ones on the north side. Let's look at the right side here. I think you have the right location. That's the right location. And then there would be one more. There'll be one more down the chain over here for the plaza water. Okay, we'll zoom in. We'll zoom into one place and see if the numbers are correct. Let's take a look at this one first. So the DI would be, the CC looks like too high. No, we're going down. So the CC should be below 8. Okay. So you might have had like 7.95 or 96. This looks like 7.8 something. It's not that close to the 8 contour. You would measure the distance from here to there. You would measure this distance and use 2% to calculate that, okay? And then use 2% to calculate these. These would be, if they're symmetrical, that would be the same. Looks like you don't have symmetrical. The curve is not symmetrical, so they might be at different elevations. So if we use the DI or the curve cut as 7.9, it seems like we're making this very deep. Okay, those are very low. If my parking lot is here, my curb is over here, and this is my plaza. That's my plaza, right? Or green area. Yeah, you're at a green area now. We're discharging water at 7.9, and I don't necessarily want to pinch my water down here to 6.5. Okay, that's a pretty big drop. Okay, then the bottom would be even 5 point something. So you can see that we're creating a pretty big drop from here to the bottom. And it seems like we're doing it with the wall. Does that make sense? So if you drew this in cross section, it looked like this. It looks like we're creating a wall, and then a deep cell where it comes out, what it comes out, a drop of 1.4 at least. And then you definitely need rocks over here. Now, this is creating a waterfall type of feature. Does that make sense?
Yeah.
Yeah, so if you don't want a waterfall feature, which I think in this case will be better. Now, the slower you can make water, the better, right? So you can raise your RDI to 7.5, and then you raise your low point to 6.5. That's the bottom. The bottom of the cell would be 6.5. And I would also suggest getting rid of the wall here, basically making it a sloped entrance like this. Okay, a sloped entrance meaning that you have a 7 contour that is a closed contour. Okay, your 7 contour would just be a closed contour, wouldn't hit the curve. Okay. All right, so that's that one. Let's look at this one. So correct location, I'm not exactly sure. Oh, okay, you cut off this one, that's okay. If that's the case, you would get rid of this line, these lines, right? Because your curve essentially goes like this, right? So that's that one. We have 11.05 or 10.92. I don't think you are, yeah, same thing, same issue. Same issue. This wouldn't be higher than 11. We're going down all the way. This is determined by the surface of your parking lot. Okay, parking lot contour here is 11. We're below 11. DI, again, you would measure this and then use 2%. So the DI here could be even 10.5. Okay, could be close to 10.5. If this is 10.5, your RDI can be 10 and your LP can be 9. And then you have a 10 and 9 contour inside of this one. And between your 10 and the other 10, this is the 11. Okay. Between your 11 and the original 11, you would have a high point. Okay. Does that make sense? So you would have a 10 contour inside, and then another 9 contour just because your LP is 9. Your 11 contour will actually wrap around because it needs to be higher. Okay, your 11 was 11 connecting here even? No. Okay. We'll need to look at the bigger picture where 11 originally connects. Okay, I see 11 now. 11 was originally here. Okay, it cannot cross the other contours. So definitely your DI is a tad below 10.5. So your 11 needs to wrap around on the high side. And then you have your 10, and then you have your 9. Does that make sense?
Yeah.
Okay. So that's for that one. I think I went through all 3. Any other questions?
No, I don't believe I do.
Yeah. I would say the grading happening here is a little excessive, right? If we connect closer to our contours here, you wouldn't be needing to do this much. I'll give you an example. This is a 12. That's 13. Yeah, that's 13. 12 is over here. Okay. If we, for instance, start connecting 12 like that instead, and start to connect 11 from here, I know we need to create some space for retention, but we can localizely kind of include, make this one bigger like that instead of connecting farther to that side. Okay, so for the 10, you could start from here, and then even do this, and then you can have a retention area in between. Again, you can get rid of that curve. Does that make sense? So this way you don't need to keep pushing the contours further down that way. Okay. Okay, so that's that. Any other questions, Senator?
No, I don't have any right now. Thank you, though.
Okay, good. All right, Jane. You unmute. Jane, can you unmute to let me know you're here?
Yep, I'm here.
All right. So I see some contour conflicts in this area. Okay, we need to keep pushing a few until you don't have any conflicts anymore. Yeah, there are some conflicts here as well. Okay, some conflicts over here. We're missing contours at the bottom here. Okay, so those are sort of zooming out. I see some contour issue. Okay, some base map revisions that remains to be done. We talked about if our parking space starts there, your curb would look like that. The curb would look like this. Okay. And then rounding these corners so you don't continue to lose points for these. Those are things that remains to be done. Well, the sidewalk doesn't connect to anywhere. If you might choose to get rid of the sidewalk over there, or you could continue that sidewalk over. But that sidewalk might not be used that much, just because you'd have to create a destination for people to use something, right? People has to have a reason to go somewhere to use that one. Okay. Now let's take a look at your retention area. So we have one of that here. The location is good. We definitely need someone here, right? Because that's the lowest point. For this one, we'll zoom in to like take a look at that one. I'll need to know the contour number again. So that's 6, that's 5. So that's should be 7. That's 7 over there. Or no, that's 6. So this is 6, and that is 6. So what you would use would be using, well, this looks like pretty close to 5. Yeah, okay. That's the lowest point. Lowest point is somewhere, feels like somewhere here. Yeah, that's the lowest point. So your curb cut and DI would be in this location instead. This location instead. And then that's slightly above 5, right? So the curb cut here, the elevation is not right. It needs to be determined by your adjacent contour, which is 6 and 5 there, okay? So this would be about 5.05. If that's the case, the DI might be 4.9. Your LP works, your HP works. Your LP and HP works, okay? But the DI cannot be out here in somewhere random. It needs to be, the DI needs to be here, all right? Choose if you want to have a DI or an RDI. If it's a DI, it's right there. You would have a DI, and then you have two curb cuts on either side, okay? So that's that one. For this one, you do not have a curve. No curve here, okay? This is already above at the plaza level, so there's no curve. And your retention would be moved to on the swell line. Okay, that's where your retention needs to be. And then yeah, the elevation seems too low, right? Your the edge of the plaza is at about 106, and your LP is 2.5 foot low, okay, below. So you're creating a deep hole that is not necessary, as I just mentioned to, I think that was Sanders' example. We don't need to drop that much at the edge of the plaza. Okay. So let's take a look at this one in the middle. So you have curb cuts, and the curb cuts are at this location. Well, here you would want to, again, take a look at where the good position would be for the curb cuts. So you would be, yeah, you made it right here at the tangent point. That's good. Now we want to, that one is a higher one, and they wouldn't be at the same location elevation, right? You calculate this one, it would be above your which contour this is, the 7, Okay, this is the 7 contour. That one will be above and this one will be below, right? This is should be 6.8. And that one looks like it's 7.3. Okay, so those are based on their actual elevation on the parking lot. Now you use the lower one, right? Use the lower one to determine your water level. So your LP would be above 7, okay? Because the entrance of your flow, is 6.8. So your LP would need to be 5.8, okay? 5.8. And then the contour here, you wouldn't have 102, 108, okay? There was a contour in the middle that should be, I'm a little confused. I think that the contour numbers are probably labeled not correctly. Let me clear and zoom out and see. So this will be 8, 8. That's 7, 7. So that's 8. Okay, if this is 8, that is 7, then this was not labeled correct. Okay, in that case, you know, these are 6 point this is 6 point something, and that is 5. I believe, you know, your line hierarchy, what led me to think of this as 5 was the line hierarchy here, but this is actually 6. So definitely, you know, try to add labels to all of your contours. Make sure they're not wrong. No, now this 5 is connected to 4, so that's definitely not right. Okay, that's connected to 4. This is connected to 5. So now go through every of your contour to make sure that you're connecting to the right one. And because of that, this is 8, so you have an 8 in between. That's correct. You have an 8 here. That's right. This is 7.8. That will be right. And you would have a 7 contour. Yeah, so instead you would have a 7 contour and then an 8 contour. Okay, not 2 108s, but 1 107 and then one other 108. Okay. I think I answered questions that you labeled. Your bioretention areas, they'll make them as big as you can. When you have flat space, make them big. Placement for more parking lot bioretention, I don't see. You have additional ones, but you would have retention somewhere here, there, at the end of the swale here, more holes in the middle of the parking lot. Even something here would help, or you can cut down your pavement area. You know, if you only need to walk from here to you may want to restrict where people can walk. So if you want, you know, to drop people off from here, then you might be able to concentrate that you know, impervious area in the middle, but then save something. Yeah, you have another connection here. So it does feel like you have a lot of need for pavement. In that case, try to cut holes where people are not walking. Okay. You need some at the end of the cell here, and there's some need over here, but not critical because there's only a pretty small. Well, let's put this at the end then. Put this at the end before it gets into your turnaround. Does that make sense? That's for the parking lot and for the plaza. And then, like I said to other people, you would have something at the backyard for your plaza and for your roof drainage. Does that make sense?
Yeah, that makes sense. Yeah, thank you.
Anything else you want to go through?
No, I don't think so.
Okay.
Nope. Okay, thank you.
All right, you're welcome. Okay, our last one, Shelley. Thanks for sticking around to the end. Let's see. There are some conflict of contours issues. Not drawing it very well, but you get the idea. Okay. The annotation would be easier. So these conflicts needs to be solved. Base MAC hierarchy is an issue, so definitely talk to Jonathan if you haven't reached out, or Kyle. The swale line is very close to your building, so I would at this stage I would rotate the building. Rotate the building to the side here. So the swell line, you can see that your swell line is going directly into your stairs. That's a drainage issue, or it's a pretty big one. So let's just turn the building away so it doesn't have that pattern. Okay. There's some contours that are not correct. For the 107 here, that's not correct. The contours at some point turned, which is okay. So it would be like this. This contour will be like that. And then that one can go like this. So we'll hit the retaining wall instead. Then this goes like that, actually. If you're, does that make sense? This one corresponds to that one. Yeah, this one is like this. And then you wouldn't have, yeah, you would not have another one because 107, there's not enough 50, not 50 feet for you to have 106 there. So it's a closed contour of 107. Okay. 8, 7. You can try to see if this is 25. I'm not sure. You may have something that goes up like that. Okay. So if this is over 25, then you would have your 107 kind of, wrapping up. You would have some 107 coming out instead of being a closed contour, and your 107 is somewhere here. Okay. And then this one would just be basically go hit the wall there. 08 and those, yeah, 6 and then 5. Okay, those are the contours that I can see. Let me 110, 112, 103. That works. This comes out like that. Not sure where 1109 comes out. It does feel like there's another 1109. So that looks good. This one looks good. No, going through that and coming out of there. That looks okay. But there's also a portion that goes out from here. Somewhere it needs to connect back to the 09 there. Something's turned again for the 1108. Let's see. So it feels like it should go this way. Yeah, it needs to go that way, and then it goes this way. The 1108 would do this. Okay, this is And then that's 75 foot. All right. Let me try to save part of this. Okay, I'm gonna clear this and then I'll take a look at the retention area. Let's take a look at this one. The location is good. Okay, the location is right there at the end. We'll need to calculate the CC here because LPS, the 106 was wrong. So CC likely is wrong too, but it's okay. Let's use your numbers and see to check the relationships. Then you know, okay, the relationships are correct. I just need to recalculate the curve cut, right? So the curve cut, suppose it's 5105.95 RDI 80. Your LP is a little low. No, your water depth. Let's make it 1. Okay, at most would be 1. And then you would have a 105 contour. So I would say, I want to draw it out again. So that feels like this is your 1107. Yeah, 107 goes out like that. 107 goes out like that and goes back here. 07 because the CC is 6 point something, you have a 6 contour. Okay, so there's a 6 contour somewhere. And then you have another 6 going around. So your high point will be here, 6.5. Does that make sense? Yeah, okay. I returned back to the current elevations because I need to know how contours are, right? Your 7 is this is the first 7. And then the 7 goes, the other part of the 7 goes around and then hit the retaining wall, but you would have a 6 that goes around the whole thing and connect to the retaining wall. So your outside contours are 7 and then there's a 6. Your inside contour in the retention is a 6. So you would put HP equals to 6.5 between your two 6. Okay? So that's that one. Let's take a look at, you have one of those there. Yeah. You're not getting water. You're not, yeah, you're not, you can have one here for, just for the green area, but it doesn't have to be big. It can be a depression. It doesn't have to have, you know, because it's a green area. It's beneficial to have something there for your green area, but you don't have to engineer it because it doesn't come from pavement. All right, and have a depression there. That's fine. Honestly, I would probably not focus on this one. I would focus on making the other ones correct. Yeah, because this one is it's unnecessary, right? It's unnecessary. The drop-off area, yes. Let's basically outline for your side here. It's a little hard because all the water basically shoots down there, right? Just down to the swale. So wouldn't be beneficial to have anything there, unless you do a trench. Oh yeah, okay. So in that case, yes, you have these. You have each cell would be corresponding to one trench ring. I went through the trench ring with Matthew. Yeah, so you can flip to these. Then you can see how trench rings work. So those are for the trench rings, and that's for the final one. Not in the middle, no, not necessary. Here you would need some because water is drained to the side. See that, right? Water is draining to the side, so it's beneficial to have. And this one you have here is good. That location is good. You do need something over here because that's the lowest point. You see that this is the lowest point of your turnaround. So that's a good place to cut a hole in your plaza. And then at the end of this chain, once you are able to move you rotate the building away, you want to have off the vegetation. No, sorry, off on the vegetation. You could have holes in your plaza, and then you can have one more that's on the vegetation. Okay. No, you don't need that. Yeah, make a hole in the plaza, then green areas, because they're relatively high, they're not receiving water from pavement. It's fine to leave them alone. Yeah. All right. Good. Yeah, you're welcome.